Okay, so in this video, I want to share with you a question I got recently that I think it's important for a lot of you to hear the answer to this. So I'm going to read you the question first. It's about a student who is in mechanical engineering and he wants to know if he can become a data scientist. Okay, so he says, "Hello, I am a fourth year student of mechatronics engineering at mechanical engineering faculty. Through my studies, I have built a strong foundation in mathematics such as linear algebra, calculus, etc. Although probability and statistics are required for learning machine learning, I haven't studied them, but I can do it online. Also, I got some experience in programming, but not in Python, but I think it shouldn't be hard to switch to it. Also, there are a lot of resources online. Also, I had some basic computer science classes. Field of mechatronics is fairly broad, so I have to specialize somewhere. I always had interest in machine learning, deep learning, AI, etc., but I didn't have a chance to study them and I had too much work at faculty to start learning them on my own. Now I have more free time to pursue my interest, and I am looking forward to learning machine learning. And I have seen your courses on Udemy, and I think they are a great place for me to start learning. There are a few things that got me worried, and I wanted to ask someone who is an expert for an opinion, which is the reason I am writing to you." Okay, so then he says, "I would want to eventually work at this field and pursue it as my professional career, but what I am seeing online when people talk about getting jobs in this field, they say that I need a bachelor's in computer science or data science or mathematics, etc. But what I am getting next year is a bachelor's of mechatronics, and I'm afraid that companies won't hire me without these degrees, even if I learned the necessary skills online and through courses. So is there hope for me? Can I get a job in this field having my degree? Would you encourage me to continue learning machine learning, or should I look somewhere else? If the answer is positive, another thing I would wanted to ask you is what exact career path would you recommend me to pursue having my degree? Can I succeed in getting a job as a machine learning engineer? What about data scientist?" It was probably exhausting to read through all of this, but thank you for reading, and I hope you answer me with some good advice. Okay, so thank you for your question. And so in regards to needing a bachelor's in computer science or data science or mathematics. Okay, so firstly, this is absolutely not true. So some of the best data scientists I've met studied physics, in fact, which has many of the same math prerequisites. So if you want to do something like quantum mechanics, you would need to study calculus, linear algebra, and probability, which is the exact same thing you need for machine learning. And you have similar prerequisites for general relativity. And so all of modern physics really depends on the same math. And so another interesting fact I wanted to mention is that I know a lot of you are interested in finance. And so it turns out that a lot of quant shops often hire physics PhDs, so people who have earned their PhD in physics. It's actually very common. And quants, if you don't know, are basically very advanced data scientists. They apply data science to finance. Now, should you be worried if you have a degree in engineering or you are an engineering student and you want to become a data scientist or an engineer? So basically, as you've seen, even with physics, it's essentially equivalent training. You're going to get training in programming and all the necessary math to prepare you for machine learning. Now, you might miss a few things. For example, if you didn't take computer science, you might be missing the finer points of algorithms and data structures, as well as databases. So, for example, binary trees and sorting algorithms and so forth. And you probably won't get as much practice coding. And now, for people looking for a degree actually called data science, I would actually encourage you to probably avoid those degrees. Any degree called data science or data analytics, in my opinion, they seem to be taken less seriously compared to more traditional degrees like computer science or engineering or physics. And basically the reason why is because I feel like the data analytics degrees tend to be less rigorous than these classical STEM subjects. And so as for what would be a good path, if you were an engineer and you just graduated from your bachelor's in engineering, what might you want to do next? Okay, so if you have all the math you need, calculus, linear algebra, and probability, you can probably just jump straight into learning machine learning. Now, this particular student said he didn't have probability yet, but that's definitely something he can pick up, applying the knowledge he already knows, specifically in calculus and linear algebra. Okay, so after doing that, you actually have all the prerequisites you need to start taking my courses. Okay, so you could go to the catalog at deeplearningcourses.com. And then if you're not sure about what order to take these courses in, you could go to the course order page. And then there's a whole list of programs. So If you want to do deep learning in depth, you could do deep learning in depth. If you want to do it applied, you can do it applied. And there are lots of different application areas you can look into. So reinforcement learning and control, computer vision, natural language processing. So pick one of these. Or there's also a program where you can just do everything. But definitely look at this, and this will take you from the prerequisites you learned in engineering, which are calculus, linear algebra, probability, and programming, and then jump off from there into one of these courses. Okay, and another question the student has was, if you didn't study Python but another programming language, can you pick up Python? And yes, that is very easy to do. Okay, Python is one of the simplest languages. You can probably pick it up in a day, maybe a week. Okay, so it's not that hard. Now, another thing I wanted to show you guys, because it's not particularly well known in my opinion, in my experience, is if you go into graduate school for engineering. So I chose the mechanical engineering department at U of T, mechanical engineering obviously because that's where the student is from, and U of T because that's the home of our godfather of AI, Geoffrey Hinton. Okay, so if we look at some of the courses they have in their graduate program, so that's if you're doing your master's or your PhD in mechanical engineering, here are some of the courses you would get to take. Okay, so you'd have topology optimization. That's probably some kind of math, not particularly relevant to us. But look at here, they have financial engineering. So that's something you might be interested in. I have my own course on financial engineering, as you know. So that's related to data science. Okay, so a lot of graduate courses in engineering are definitely in the realm of data science, for sure. Okay, some of these are not relevant to us. These are more mechanical engineering focused courses. So combustion and fuels, that's definitely not data science. Fuel cell systems. Okay, biotransport phenomena. But I remember there being a lot here. At some point, we will get to it. Okay, decision analysis, that's probably related to machine learning, but there's no description here. Okay, but if we go down to the next one, dynamic and distributed decision making. So what is that? Well, it involves Markov decision processes, reinforcement learning, game theory, multi-agent reinforcement learning. Okay, so a lot of advanced reinforcement learning concepts that you will learn in this course. Okay, so we have more mech stuff. So advanced dynamics, that's mechanical engineering, vibrations, acoustics, and noise control. But they're also interesting. I mean, like if you have the prerequisites and you want to take these courses, they do seem pretty cool. Okay, so we have sensor networks. That's probably not that relevant. We do have signal processing. So signal processing, it's very similar to time series analysis. It's basically a different perspective on time series analysis. So if you took this, you'd be learning a lot of the same stuff that you'd learn in time series. Okay, and then we have control analysis methods with applications to robotics. So control is basically, again, like signal processing, it's kind of a different perspective on reinforcement learning. Okay, how do we control systems? Okay, so then we have AI applications in robotics. So that's definitely AI. And again, part 2 and part 3. Okay, so 3 courses in AI applications in robotics. Healthcare robotics, probably not relevant. Not relevant, not relevant. Okay, so here we're back to stuff that we might be interested in. So we have statistical models and empirical research. So as you know, if you've taken my courses in the past, there's a very big overlap between machine learning and statistics. So you would definitely learn a lot of useful things in that course. And then we have, here we go. So here's data analytics, which is obviously related to data science and machine learning. Okay, we have, here we go. So structured learning and inference. So this is basically advanced machine learning. You're going to learn about probabilistic graphical models, probabilistic programming, and deep neural networks. Okay, so very advanced machine learning techniques. And here's Introduction to Deep Learning, obviously relevant. Integer programming for research students. So integer programming is an optimization method. Maybe not super relevant, but definitely related. So if you get a job in, advertising or some related field where they use data science, this could definitely be something you use. It's a strong possibility. Okay, then we have stochastic processes. This is basically, the engineering version of time series analysis. And this is applied in various places in machine learning. So as an example, if you get deeper into financial engineering, you would be applying stochastic processes. If you study Markov chain Monte Carlo, or you apply Markov chain Monte Carlo to estimate certain quantities, for example, in Bayesian machine learning, you would need to know stochastic processes. Okay? And we have stochastic modeling and optimization. That's probably related to what we do. Stochastic programming and robust optimization. So these are mathematical techniques that probably would be useful in data science and machine learning. Stochastic simulation, maybe. Markov decision processes. Okay, so definitely related to reinforcement learning, machine learning. Constraint programming and hybrid optimization. So more optimization stuff, probably more relevant to mechanical engineers than data scientists. Linear programming and network flows. So yeah, they really like this optimization stuff in mechanical engineering. Okay, nonlinear optimization, same thing. Computational finance and risk management. Okay, so a lot of you who are interested in finance, you can see how, with a mechanical engineering degree, you could still get into finance. In fact, when I mentioned before, physics people get into finance, so too do mechanical engineers. Okay, I've met more than one. Introduction to healthcare engineering, no. Okay, so introduction to data science and analytics. So you can already see there are more than a handful of courses in the data science area, even though you are in mechanical engineering. Okay, you could take a mechanical engineering degree and basically have all your courses be in data science. Okay, introduction to data science and analytics, I think that's the same one as above. Data science methods and quantitative analysis, so obviously that's data science. Cloud-based data analytics, so basically you're doing data stuff in the cloud using technologies like Hadoop, MapReduce, Spark. So I've covered some of that stuff in my courses. It's not machine learning per se, but these are the tools that you could be using on the job as a machine learning engineer or data scientist. So practically speaking, these would be useful, even though it's not an actual data science subject. Okay, but you could be using, okay, so they're saying cloud-based implementation of real-time analytics and machine learning. Okay, so you could be actually using machine learning with these technologies in this course. Okay, so what else do we have? Same stuff, integer programming. So machine learning for mathematical optimization. So obviously related to us. Statistical methods of quality assurance. Probably, so this is kind of in between data science and mechanical engineering, but could still be useful. Okay, so that's the end of this list, but you've seen there are probably, I think probably around 5 to 10 courses we found that are in the field of data science. So yeah, if you are in mechanical engineering or any other kind of engineering and you want to get into data science, this is perhaps a path you could take. You could go to graduate school and then take courses like these.